Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture, and we were doing section number 6, automated and emerging technologies. We have done section 6.1 and 6.2 in our previous lectures. So today we are going to discuss section 6.3, that is artificial intelligence. Artificial intelligence, or AI as it is used, it is the simulation of human intelligence by machines, especially by a computer system. Specific applications of AI includes expert system, natural language processing, speech recognition, and machine vision or machine learning. AI is a branch of computer science that deals with the simulation of intelligent behaviors by computer as they would be performed by an actual human. There are three types of artificial intelligence or AI: narrow or weak AI, general or strong AI, and artificial superintelligence. Currently we have only achieved the narrow AI, and if we achieve a strong AI or artificial superintelligence, then we might just be seeing something that would look like it's out of a science fiction movie. Narrow AI is goal oriented and it is designed to perform a singular task. For example, it is designed to a system that is designed to perform facial recognition, speech recognition, or a voice assistant, a self-driving car, searching the internet, and it is very intelligent or very capable at completing the specific task it is programmed to do so. Narrow AI is superior to human performance at its specific job, not in more than one scenarios. Artificial general intelligence, or AGI, is also referred to as strong AI or deep AI. It is the concept of a machine with general intelligence that mimics human intelligence or behaviors in multiple aspects. It can think, understand, and act in a way that is indistinguishable from that of a human in any given situation, or you can say it is on par with human behavior. Most of the time when you see an AI in movies, science fiction movies, that is often mimicking a mimic of AGI, such as the Jarvis AI from Marvel series. That is an example of AGI. Artificial superintelligence, ASI, is the hypothetical AI that doesn't just mimic or understand human intelligence and behavior. It is where machines become self-aware and surpass the capability of human intelligence and ability in multiple tasks. An example might be that of the Matrix from the Matrix franchise, a movie series trilogy basically, and the Matrix over there is it is made up by a very self-aware machines. So that is basically a scientific, what you can say, a portrayal of ASI or artificial superintelligence. And even in the real world, scientists and programmers or researchers warn that if we truly achieve this level of intelligence in real life, it would be very disastrous, and the AI or the machines or the computers may very well turn against humans in reality. Anyways, that's only for the future to told. Now, the next thing you need to know are the characteristics of AI. The ideal characteristic of an AI is the ability to rationalize and take actions that have been the best chance of achieving a specific goal. The following are the characteristics of an AI. The first one is reasoning. It is the ability to solve problems through logical deductions, and the term applies to a machine that can reason and it can solve a problem through a logical deduction. The ability to learn. AI programs or machines have an ability to learn new solutions, but conventional systems do not have that level. Adapting. The AI system is capable of learning and adapting to its surroundings or environment. If you change the inputs or the surrounding or the conditions or the environment, AI would be able to adapt itself to the new environment and still get you the required output. AI can very quickly discern or learn patterns, which in some cases humans cannot, and then make predictions by adapting to the new data. Another type of artificial intelligence that is now a part of the syllabus. This has basically been taken from the old syllabus of computer studies that was ended in November 2014. Expert system. It is a computer program that uses AI to simulate the judgment and behavior of a human or an organization that has expertise and experience in a particular field. Or in short term, expert system is a software that can mimic the expertise of one or more than one human experts in a specific field. Examples of AI includes medical diagnosis, financial planning, chess games, mineral prospecting. Mineral prospecting is a process where you feed the geological surveys and geographical reports of an area to a computer system, and the computer system predicts that whether how much of a specific mineral you can get from that area and whether the excavation would be beneficial, a loss, or break even. Route scheduling, calculating systems, etc. Expert systems are usually intended to complement and not replace human experts. Components of an expert system. There are three main components. The knowledge base. This is where the information is stored, or it is a repository of information that makes the expert system work, and it is filled by multiple human experts providing facts about the expert system's particular subject. And they are kept in an organized way. It often contains a knowledge acquisition model that enables the system to gather knowledge from external sources such as internet and store or amend it in the knowledge base. Next part is the inference engine, and this part of the system pulls relevant information from the knowledge base based on the answers that or the questions that are provided by the user. It is a rule-based system that is also known as inference rules, which maps known information from the knowledge base to a set of rules and makes decisions based on those inputs. It often includes an explanation system as well, so that along with the results, the system or the software explains the user that why it has chosen a particular set of data as an answer to the user's queries. Last but not the least, it contains user interface, the part of expert system with which the user interacts to get an answer to their problem. Now, what are the advantages of expert system? They are not prone to human errors or emotional influence. Human experts eventually die, or they retire, or they simply age, whereas expert system or computer software cannot go down with age, or it doesn't have that problem. In fact, the knowledge base of expert system just keep on expanding, or you can say it simply serves as a permanent repository for knowledge and information for eons and eons. Expert system draws conclusion from existing facts, thus they are more logical, whereas a human may be more emotional. They are relatively inexpensive compared to cost of employing human experts. Multiple experts contribute to an expert system's knowledge, which provide more knowledge to draw from. Disadvantages are they lack true problem solving ability, as it can't reason in a non-linear way. It has to always follow a logical way. Human intuition enables people to use common sense and gut feeling to solve problems, whereas expert systems are just softwares, so they do not have these perks or capabilities. In some cases, for example medical diagnosis, you cannot just discard human emotions or human senses without which you may get the wrong results. Expert systems are only as good as the quality of their knowledge base, and as all knowledge systems, they can be tainted if wrong knowledge is fed into them intentionally or unintentionally. This can cause wrong outcomes or wrong results. The setup and maintenance cost, or the initial setup cost, are very high. Last but not the least, users sometimes think, or most of the users always tend to always think, that it is a computer system, so it will always be error free, but that is not the case. Expert systems can make mistakes, especially if they have drawn in wrong information, or if they have had some glitches in the software. Last but not the least, we have a machine learning. ML, or machine learning, is a type of artificial intelligence that allows software applications to become more accurate at predicting outcomes without being explicitly programmed to do so. These machines, or these softwares, are self-learning, and they are able to learn solutions to new problems, although they are not exclusively programmed to solve that typical problem, such as an AI that is that has been designed to play chess soon, or with years of practice and test models, may be able to give you good guideline for, or may be able to give you good combat strategies that you can deploy in real life, a real life war, although it was initially designed for chess and not for predicting strategies for a real war. But machine learning tends to make machines that are able to adapt to new data, and they are able to self-learn, and they are able to predict new solutions for new problems on their own without being programmed to do so. The system is programmed with an ability to learn or be trained. They use historical data as input to predict new output values, such as they would use the data for a battle game's tactics in order to predict strategies to be used in an actual war. This happens by inputting data that can be recalled by the system during development. The more data the system receives, the better it will be at recognizing things later. Means the more you train the system during development phase, the much better its, or sharper its outcome would be after deployment. Computer scientists program system for machine learning by replicating some of the functions of human brains, such as the nervous system. Just as nervous system is able to you can say memorize experiences and then use them in order to take decisions later in life, the same way and a machine learning works, and it collaborates with all parts of the system in order to come up with new solutions. By producing a system that is as close to human brain as possible, it ensures that it can begin to react, adapt and change its responses based on the input it receives. Last but not the least, AI versus machine learning. AI represents simulated intelligence, whereas machine learning represents the practice of getting machines to become self-aware, or in order or to make them learn solutions to new problems all on their own without being programmed to do so. AI's aim is to build machines that are capable of thinking like humans, whereas machine learning makes the machines capable of learning through data acquisition, so that they can solve new problems. Means it gives the machines the ability to be trained by a set of, in fact, sets of multiple sets of test data, so that they are able to solve problems on their own, whereas AI can only function best in a predictable environment or with similar problems. Machine learning can tackle new types of problems. That's it I hope you have understood everything. We have covered everything that's given in the syllabus. If you still have any queries or problems, feel free to ask me. I hope you have understood everything. Take care, and I'll see you guys in a new lecture. Allah Hafiz. That's all. By the way, this is all for paper 1. All 6 sections have been covered. There's nothing else that you need to prepare for in paper number 1. So good luck. Take care. Allah Hafiz. Do let me know your comments.